So the practical one, which is about finding the acceleration due to gravity or free fall method, how we can find the acceleration of a free fall or value of the g. The material like stand and clamp, electromagnet, low voltage supply is there, a 2 kilogram mass, steel ball bearing, two light gates, and electronic clock or a data logger. So this is an experimental setup. As you can see how it works. As you can see here, we can either use two light gates, or we can also use the tap switch. So when the electromagnet demagnetize the steel ball bearing, it will also demagnetize and it start to flow. Then when it crosses the first light gate, will record the time. That time is t1. When it move to a second light gate, that will be t2. And what is our assumption? Its initial velocity is 0. So and we measure the distance between the two light gates. So we have the formula S is equals to ut plus half at square, where initial velocity, the starting velocity is 0. So if starting velocity is 0, S will be equal to 1 by 2, because this whole factor will be 0. So 1 by 2 acceleration is due to gravity. So we can say g, and then t square will be there. So the equation we will use to solve this, S equals 1 by 2 gt square. And then we'll compare with the equation of straight line, y is equals to mx. So on y-axis, if we sketch the displacement, the distance between the two light gates, or distance the ball travel when it is moving between the light gates. And on x-axis, if we have t square, so if there is t square on x-axis, what will be the gradient of this graph whenever we sketch a graph between s and t square? So the gradient is equivalent to half 1 by 2g. Or if we need a gravity, so it will be equal to 2g. So this is how we can work out the acceleration due to gravity for a falling object between the two light gates. So what we assume here, like what we neglect the effect of air resistance, we consider air resistance as negligible, and the weight of the ball bearing, which is the main reason is that because the size or the weight of a ball bearing which we are using, and using a light gate could be advantage. Why using a light gate is an advantage here instead of using a stopwatch? Because if you are using a stopwatch, then reaction time will be there, but in light gates there is no reaction time. Is it clear, the first experiment? So the second experiment, using a falling method to determine the viscosity. Viscosity means property of a fluid to resist the flow. That is known as the viscosity. So how we can work out, or how we can find the viscosity of a liquid? So we fill up, like a measuring cylinder is there. We fill up with a liquid, and on the measuring cylinder we put the markers. Rubber bands basically used as a markers, and equally spaced. The distance between the two markers should be same, because we are using the formula which relate the viscosity and terminal velocity. Because when the object does not experience any resultant force, that time it will move with a constant speed. Or we can also say, as it's a falling object, the weight which is acting downward, up thrust acting upward, and the viscous drag or the drag force which is also acting upward. So when all the forces are balanced, the object will continue to move with a constant speed, or the terminal speed. And in that case, if we relate the terminal velocity, so how terminal velocity is related with the viscosity? So it is 2 by 9 here is viscosity eta r squared g and the difference of the densities, density of object minus density of the fluid. This is a formula which relate the terminal velocity and viscosity. All the other parameters are constant, where r is a radius of a ball bearing. So we can work out using a micrometer. First we'll determine the diameter of the ball bearing, and from diameter we'll determine the radius. So we'll have the radius. Gravity g is constant. The density, because every material is having a fixed density, so these are all the constants. So the only parameters which can change, either a viscosity can change or a terminal velocity. So if we want to find the viscosity of a liquid, like we want n, so we modify this formula that viscosity, basically that is eta, equal to 2r square difference, 2r square g, difference of the density of the two medium, density of object and density of fluid, divided by 9 and v. So the only thing to get the viscosity, like we need the size, because gravity is constant, density of the object and the object from density of a material from which this ball bearing is made up of, that is fixed, that is constant. Density of the fluid also constant. So we have to determine only r and we have to determine v. How we can determine r? We'll make using a micrometer or a vernier caliper. We'll find the diameter, and diameter divided by 2 will get the radius. And how to get the terminal velocity? So to know the terminal velocity, so what we will do, we place markers here. Why we did not place marker at the top of this measuring cylinder? Because the moment we drop the ball bearing, it will not reach the terminal velocity. It will take some time to reach the terminal velocity until all the forces are balanced. That's why the rubber bands are placed, the markers are placed at the bottom near the base, and they are equally spaced. So how to know, how to identify whether it reaches the terminal velocity? So we'll measure a time to fall from one marker to another, so distance divided by time will get the speed. And same thing from moving from marker 2 to marker 3, the distance divided by time, we will get the velocity. So, and we'll take an average, but the problem here is a reaction time. As a human error, reaction time is there as we start and stop the timer in a short interval, so there is always a reaction time. So we will have the v, we have the r, so we'll substitute these values, we'll get the viscosity. But whenever experiment is done, because we repeat the experiment and we plot a graph, so which quantities we should plot a graph here? So if we use this equation, so we have this equation that terminal velocity is equals to 2 by 9 r square gravity difference of the density of object minus density of fluid divided by 9 eta. That is the formula. Now, because we are finding the terminal velocity and we are finding the size of the ball bearing, so we'll repeat the experiment with different sides of the ball bearings. So they will have different velocities. So if I modify, it will be v is equals to 2 g, the difference in the density, density of object, density of fluid, r square divided by 9 eta. Now if I compare with the equation of straight line, on y-axis if I have the terminal velocity, on x-axis if I plot r square. So when on y-axis we have the terminal velocity, and we are changing the ball bearing, so the value of the r square will change for different samples. So on x-axis we have r square. So it will be a straight line because all the constants are involved. Even the viscosity of an object is also constant. So all the constants are involved. So here the gradient of this graph, the whole this factor which is left behind, This whole factor is equals to gradient. So the gradient of this graph will be equal to 2g, the difference in the density of object and fluid, divided by 9 eta. And if we need eta, the viscosity, so that is equals to 2g, the difference in the density of object minus fluid, divided by 9 into the gradient. So this formula we will use to work out the viscosity of this fluid. The third experiment is finding the Young's modulus, how we can work out the Young's modulus. So Young's modulus is basically stress divided by strain. And what is stress? Stress is force acting on unit area, and what is strain? Change in length over original length. So when we simplify this equation, it will be FL divided by A delta L. So so what we need the force. So basically what we'll do, we'll take a wire, one end of the wire is fixed and the other end is passing over the pulley, and we attach a load. So what load we attach, that is equals to the force applied. So that is the force applied. Then we'll place a marker on the wire, like example, or we can just place a mark here anywhere. That is the length which we are using. Example, we place a tape here or the marker at position A, and we measure the length before the part which we are using before attaching any load. We measure the length, that length is called L. But the moment when, so we'll get the length, you'll need a meter rule or a meter scale. What about area of cross section of wire? So before the wire is placed between in the setup, so we'll determine the area of the cross section of the wire. How to determine the area of cross section of wire? So we'll first find diameter. Same way, we'll first find a diameter, and using a diameter, half of diameter, we'll get the radius, and area of a cross section of wire is pi r square. So using A equal pi r square, we'll get the area. What about the change in length delta? Because the only factors, L will remain constant, like that is the original length, and area also we assume it does not change. Practically, area of cross section of wire will change as you are stretching a wire, but we assume areas remain constant. So the only two factors which will change is the force which we are adding, the load which we are adding, and how much the wire increases the length or how much the wire changes the length. So what is delta L? Delta L is always how much the marker has moved. So we measure the initial position, then the moment we add a load, there will be a new position, like the tape as a wire will stretch, the position of the tape will change. Example, this is a new position of the tape. So this is L, this we say L1. So when we take a difference of the new length minus the original length, say this is the original length, this is a new length. So when we take a difference, what we'll get the change in length, or we call that as delta L. So, and we'll repeat the procedure with different set of loads, and we'll get a different lengths. We'll substitute the values and we'll get the final answer for the Young's modulus. But practically, whenever we do the experiment, we prefer to plot a graph. The reason is that when graph is plotted, we can identify whether there is a random error or systematic error. Because if there is a random error, then the variation between the values might not be same. If it is a systematic error, every time you will get a same difference from your value to the standard value. So what we can do, we can sketch a graph here. So what graph can be sketched? We can find the stress, which is force divided by area, and we can find the strain, which is change in length over original length. Plotting a graph between the stress and strain. So on y-axis we have stress, and x-axis we have strain. So when we sketch a graph between them, the slope, what it represents the Young's modulus, which is equals to stress divided by strain. So as you can see here, detail of a wire clamps are not shown in this figure. So we have the test wire, the original wire is there, like this is a comparison wire compared to this wire, how much it has changed, the length has changed. So using that we can work out the change in length, and using a change in length of the load attached we can work out the stress and the strain, and stress divided by strains will give us the Young's modulus. So the graph will between the force and extension, it will be a straight line. Or we can also use this method like horizontal wire, as you can see. Um, so what we did here, we fixed the wire. The first one was a vertical, but the second one is wire is horizontal, and then pulley is used just to clamp the weight. So this is a test wire. We put a marker on it and we add a load. So as we add a load, the wire will stretch the position of the marker on the wire because the length of the wire changes. So the position of the marker will also change. So how much there's a change in the position, using that we can work out the change in length, and using strain change in length we can work out Young's modulus. And if you want to find the energy stored, that will be the area under the graph. So stress strain graph, area under the graph will give us energy stored by the wire. Then the next one is determine the speed of sound in air using a two beam oscilloscope, a signal generator, speaker, and a microphone. So this is a two beam oscilloscope. Two beam oscilloscope means like it can produce two waves. So what happened? We have a speaker here, and this is a signal generator. So the signal generator, when it produces a signal, one of the signal, electrical signal is sent to the speaker, and one of the electrical signal is sent to the oscilloscope. So the signal which is sent to oscilloscope, it might appear like this, or you can also say it might appear like this. Like this is oscilloscope. Oscilloscope is mainly showing the waveform of different types of signals. So it can be a sound, it can be electrical signal. So what happened when we produce using a signal generator, when we produce a sound, so directly one of them is going to the oscilloscope. So oscilloscope read the value. So example, this is a sound which is received directly from the signal generator. But then the loudspeaker produces a sound. As a result, when the loudspeaker produces a sound, that sound travel from loudspeaker to the microphone. When that sound travel to the microphone produce an electrical signal. Now that electrical signal will travel from microphone, not microscope. So loudspeaker produces sound. That sound is picked by the microphone, and the microphone transfer that electrical signal to the oscilloscope. So when the microphone transferred that signal to the oscilloscope, there will be another peak. So basically, distance, how we can measure a distance between the cone of the loudspeaker to the microphone, that distance will measure by a ruler meter scale. And the time between the first and the second signal, because the first and the second signal, first signal which oscilloscope received directly when the sound wave started, and the second signal when it the microphone received the sound wave, so second signal is generated. So this is the second time t is there. So we have the distance divided by time. So distance divided by time, what it give us, it give us the speed. Why we are not using the Stopwatch here, because the problem with the stopwatch, it is difficult to, it's a short in time interval, so it will be difficult, it will have a higher percentage uncertainty, and difficult to identify the two sounds, like which is originated from the source, the moment it originate from the source, and the moment which is received or coming to us. So that's why we are using the two beam oscilloscope or oscilloscope rather than the stopwatch. So the same concept, same idea is that, but because we can use this experiment uh, for a shorter distance, like even if we place a short distance between the cone of the loudspeaker and the microphone, this experiment we can work out, or we can find the speed. Is it clear? Experiment to find speed of sound in air by using a two beam oscilloscope. Then investigating the variation of frequency of a stationary wave for a standing wave on a string with a length, tension, and mass per unit length. So if we want to find how the length, the mass per unit length, or the tension can affect the frequency. So this is an experimental setup. Here we have a vibration generator, basically vibration generator. A wire is, and this is a wire which is we fix from here, and then this wire is passing, like we fixed from this part, and then we are passing through the passing around the pulley, and then the weight is attached. The main purpose of the weight, because using this weight we can find how much force or a tension is there in the wire. As we are finding the effect of tension, the length, or the mass per unit length, which is also known as the thickness of a wire, on the frequency. So what will happen when we switch on this vibration generator? But the thing is, because there are three factors, one is the tension, one is the length, and the third one is mass per unit length. Mass per unit length is also known as the thickness of a wire. Like if more mass per unit length, it means the thicker wire. So we will keep, because there are three parameters which can be changed, so we cannot change all of them altogether. We have to keep two of them constant and change one. Example, first we are finding the effect of tension. So if you are finding the effect of tension, the length and the mass per unit length will remain constant. We won't change. So what we will do, how to change the tension? First, like example, the length is fixed, maybe say 30 centimeter or 40 centimeter wire is there, and here the load which we attach, that is the force or tension. So when we switch on, the wire will start to vibrate. As it will vibrate, we will measure what tension, where what load is applied, like it will be in gram, but we'll convert into kilogram. And then what about the tension here? What about the frequency? How to work out the frequency? So we have the formula. So we have the formula V is equals to F lambda, where V is the speed of wave in a string, that is constant. What about wavelength lambda? Because it is producing one loop, or depending on how many loops are produced, but we assume example if it was producing one loop. It depends on how many, it can produce multiple loops. So example, if it is producing one loop, what is the length of one loop? The distance between the two successive nodes from one node to another. It might produce a pattern like this. So then it means it will have node. So there are multiple possibilities are there. So this is the minimum possible way it can vibrate, in which there are two nodes at the end. So when two nodes are at the end, so it means the length is distance between the two successive nodes is lambda by 2. So we can say length or L is equals to lambda by 2, or we can say lambda is equals to 2L. So in place of lambda, we'll write 2L, or V divided by 2L will be equal to F. So V is the speed, L is the length, so we'll find the frequency, and we'll change the tension and we'll find the frequency again with a different number of the loops and find the relation between the frequency and the tension. And same way, we can change the length of a wire used. Like example, first we use 30 centimeter, then 40 centimeter, then 50 centimeter. So we'll change the length, but when we are changing a length, that time tension must be kept constant, because only one parameter can be changed at a time. So once we are changing the length, will keep tension and mass per unit length constant. And when we want to find the effect of mass per unit length or the thickness of the wire, that time we will keep the tension and the length of the wire constant. And using this, we will work out how these factors are related to each other. This is all about the whole procedure is there, how we should carry out. Then practical 6, determine the wavelength of a light from a laser or other light source using a diffraction grating. What is a diffraction grating? Diffraction grating means when you have an object with multiple slits on it, we call that as a diffraction grating. Like if we have only one slit, one opening, that is called only slit or gap. But if we have multiple slits, multiple openings on the object, then what we call that as a diffraction grating. So how we can determine the wavelength using a diffraction grating or the grating element? So what we do, this is called a diffraction grating, or you can also say grating element. So we take a laser light, we want to determine the wavelength, so we'll take a laser light and we pass this through a diffraction grating. As a result, what happened, diffraction, multiple diffraction will occur. Like so diffraction occur from the first gap, diffraction occur from the second, diffraction occur from the third. As a result of this diffraction, there will be bright and dark fringes. Like some regions, there will be a constructive interference, so we'll have a bright part. Like that part will be visible to us. And some region, there will be a destructive interference. As a result of a destructive interference, what will happen? So constructive and destructive interference due to the in phase and anti phase, when crest join with crest or trough join with a trough, will have a constructive interference, otherwise destructive. So here always the center will have a constructive interference, then destructive, they cancel out the effect of each other, then constructive. And this is called N1, means like first order image. Means first order image means always center will be constructive, then the next construct there will be destructive, and then next constructive is known as the first order. Then after constructive there will be a destructive interference, and there will be again constructive, which is called second order. And below also, below the center, because center is always constructive, as the path difference is zero, both the rays which are intersecting here cover the same distance, that's why always constructive. Then below the central maxima there will be destructive, and then the first constructive will come, so we call that as first order image. And then after constructive there will be a destructive, and then there will be constructive again. So this will always be a pattern which we'll observe. D is the distance from the grating element to the screen, and H1 and H2 are the distance from the center to the first order, like from first order or second order. We are, if we are taking distance from center to the first order image, that we call h1. If we take a distance from center to the second order image, we call that as h2. And the angle which the straight from angle from the horizontal line to that region, that is called, for if the first order it's called theta 1, the second order it is called theta 2. Same thing with the first order, it is called theta 1, and the second order it is called theta 2. So what is the formula which we will use? So the formula is d sine theta equals to n lambda. Here you can see this is a formula. N lambda is equals to d sine theta. So how to get these values? As n lambda is equals to d sine theta. N is the order of image, like example, which image we are focusing on. If we are focusing on the first image, we say n is equals to 1. So n is equals to the order of the image. What about theta? How to get the theta? Look, we'll have this d and we'll measure this distance h. Like this is d, the horizontal distance is d, and this one is h. H1 or H2 depending on which image we are focusing. If we are focusing on first image, then we say H1. So this will be d, the distance between the screen and the grating element, and h is the distance from center to the first order image. So using this we'll get the theta 1, because we'll use a tangent theta, because tangent theta is equals to perpendicular divided by base. So we can work out the theta here, which is tan inverse perpendicular divided by base. So we'll get the theta. How to get this d? D is basically the distance, the gap between the two slits. So the length of the grating element divided by the number of the slits. So total length, like example, say grating element is 5 centimeter long or 10 centimeter long. So the length of this grating element divided by number of the slits, how many slits are there? So we'll get the distance between the two slits. The distance between the two slits is d. So we have d, theta is there, n is there, so we can work out the wavelength. Is it clear how we can work out the wavelength of laser by using this grating element?